right, so we got a little bit of pre-calc review first, and then we'll go from the pre-calc review into derivatives. Unfortunately, there's no nice way to do this, and this section has a series of memorizations on it. There's probably 6 different flashcard-worthy theorems that we'll get to. But the pre-calc stuff should be pretty straightforward. You should be able to talk about the 6 inverse trigonometric properties, or functions, I should say. Then we're going to take the derivative of those functions. And then we're going to review all the derivative stuff we've done from day 1 into one nice little chart for you. And then, of course, you should be able to name the presidents in order of descending height. Lincoln, good start. I have no idea. Fillmore. No, Fillmore wasn't he the...
No, that was Taft.
That was Taft, right?
Who was the one in the wheelchair?
FDR.
Oh, you say he's the shortest? It's terrible. You've already ruined this recording's chance. You've already ruined it. It's horrible.
By the way, we're recording. Your parents will be so proud. That's our little Rosie. She noticed that the guy in the wheelchair was shorter than everyone else. And you're wearing a Notre Dame sweatshirt.
Yeah, like obviously I'm
Sure, that's a proud parenting moment. I got totally derailed. What are we doing? Hey, why aren't trig functions, why don't they have inverse functions? Like, for instance, the sine function. Why doesn't sine have an inverse function?
Because it's an inverse of itself.
No.
That's enough for today.
No. And, excuse me, Meg?
Because of the horizontal line test?
Correct. It doesn't pass the horizontal line test, so it's not 1-to-1, so blah, 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 which is what that says. They don't pass the horizontal line test. They're periodic, so they continue to repeat themselves often to infinity. So what we're going to do is we still want to be able to talk about the inverse trig functions, so we're going to restrict those inverse trig functions to only one period so that it passes the horizontal line test. Okay? And we get this little chart here. This is rather confusing, and you probably don't want to write that down, but what you do want to write down, if you don't already know it, is this stuff over here in blue. That tells you what quadrants will apply to which function. So, for instance, if we're talking about the sine function, that's the first line, we will apply sine only in quadrants 1 and 4. This is not something you should memorize. This is something you should be able to decipher logically. The rules are the following. There's no quadrant 3 up there. That's number 1. Number 2, everybody has a quadrant 1. Number 3, for each function, they have to have a positive quadrant and a negative quadrant. Those are the only 3 rules you need to remember. Does that make sense? So if we look at sine, sine has to be positive and negative. So we're already in quadrant 1 where sine is positive. So where is sine negative? Either in 2 or 4. Which one is it? 4. So sine is restricted to 1 and 4. Remember, sine relates to y, so we want to be below the y-axis. If we do the same thing with cosine, cosine's going to be in quadrant 1 automatically, so that's the positive part. We want the negative quadrant for cosine, and since cosine relates to x, the negative quadrant would be over there in 2, so cosine is restricted to 1 and 2. And then the rest of those are all applicable. Somebody along the line may have taught you that stupid thing that all good students take calculus, something like, I don't know what it is.
Oh,
All
that's
students, yeah.
the same thing?
Yeah,
Oh,
I don't even know, it's dumb. Did you get a new watch? What is that?
Christmas. It's a one-face watch.
It's a what?
One-face watch. Some of the proceeds go to like a charity.
But do you have to light it up? Oh. I thought it was like a
The Apple
phone
Watch.
watch, yeah. not even out yet.
I think it comes out.
Yeah,
like
stop
February.
distracting me, sorry. The other thing about trig functions, which you're not going to like, is you need to know the unit circle. If you don't know the unit circle, you better learn it quickly. You need to know that unit circle inside, outside, forwards, backwards, up, down, and in 3 languages. Okay? You have to be able to do the unit circle quickly. So for instance, in problem, or part A, I want to know where is the sign equal to negative 1/2. There are an infinite number of places where the sign is equal to 1/2. However, we're restricting it to only two quadrants. Whereas sine, as we talked about earlier, sine is restricted to 1 and 4. So where is the sign equal to negative 1/2?
On the quadrant?
No, what value? Jesse.
7 pi over 6.
And?
11 pi over 6.
Nope. You need one from quadrant 1 and one from quadrant 2. I'm sorry, 7 pi over 6. You said 7 pi over 6 and 11 pi over 6?
Yeah.
There's a y, so no, not both of them. Which one?
11 pi over 6.
11 pi over 6. But since we're restricting it, you would actually give the answer of negative pi over 6. So one of the changes that we're going to see when we start restricting it to quadrants is normally, when you look at the unit circle, he's talking about 11 pi over 6 being over here because we start at 0 and go all the way around to 11 pi over 6. However, we're actually going to deal with going up for positive angles and down for negative angles. So from this point on, 11 pi over 6 will now become negative pi over 6. Okay, makes sense?
Yeah.
All right. Okay, get rid of that, and let's move on. So that's what I already said. This means the inverse function if we want to convert it. Now, are you okay with the conversion from this to this? Do you see how I did that? The simplest thing to do is to realize that arc sine, by the way, arc sine, I'm assuming you guys know this stuff, but maybe I shouldn't assume. Arc sine is the same thing as the inverse sine. Did you know that?
Now I do.
Not, well, obviously. It hurts when you get punched in the face. Did you know that? Now I do. Yeah, these are the same thing. Okay, and then that's not a reciprocal, that's an inverse function. And so the easiest way to think about going from this first statement to the second one is I took the sine of both sides. So the sine of y is equal to the sine of the arc sine of negative 1/2. And what happens when you take this sine of the arc sine? Cancel each other out, and we get this statement there. Okay, so that's how it came about. So we convert the inverse into a simple equation. In other words, we want to know where is the sine equal to 1/2. And so we get that negative pi over 6, same thing as 11 pi over 6. Okay, remember sine relates to y, cosine relates to x. We talked about big angle, little angle, medium angle. Yeah. All right. Where's cosine equal to 0? And? Good. Which one? Would you answer both? Does only one work? Both 2 answers?
Both.
Both?
Yeah.
But then it's not an inverse function.
Positive.
And you'll see back in that original page there were some less thans or equal to and some less thans.
So wait, why is it not negative?
Because you have to pick one or the other, and they just chose to use the positive as the one to use, not the negative.
But if we chose negative, would it be?
It would not be correct. Yeah, you gotta take the positive one. Where's tangent equal to pi over 3? Pi over 3, sorry, that's a square root. I have trouble with math. I don't bother figuring out where the tangent is equal to square root of 3. And I don't know if this is going to help you or hinder you, but the way I do this is I say that's the same thing as the arc sine of the square root of 3 over 2 over the arc cosine of 1/2.
Nope. Nope.
Okay,
Put that
well,
away.
that's fine.
Yeah.
Because I'm always looking for 1/2 square root of 2 over 2 or the square root of 3 over 2. Okay, so I like to do it as a fraction. If this doesn't work for you, then do whatever you need to do to figure out where the tangent is, the square root of 3. By the way, what quadrant are we in here for arctangent of square root of 3? Quadrant 1. And so we're looking for somewhere in quadrant 1, if you're using my method, where the y value is big and the x value is small. Wow. Let's try that again. That's better. In quadrant 1, where the y value is big and the x value is small would be right there. Where is right there? Pi over 3, correct. For those of you that don't use this fractional method, how are you going to figure out where the arctangent is equal to the square root of 3? Do you just memorize? Or you just have no clue? Okay. So you might want to try the fraction method. You don't understand the fraction method? I put where? Here? Here? Well, you realize that tangent is sine over cosine. So therefore, arctangent would be arc sine over arc cosine. And using these 3 fractions, I have to come up with a value equal to the square root of 3. So that would be this over that. Okay? I think the wheels may have just come off. All right, how about the arc sine of 0.3? Where's that on the unit circle? Good. Trick question, it's not. So Tyler's taking out his handy dandy calculator and he's going to make sure he's in radians mode. You should always be in radians mode.
30469.
3 decimal places, AP standard, get it right. Good.
I didn't know if you wanted to round out.
Always follow the rounding rules. 5 or higher, round up. Less than 5 round up. If the thing you're taking the arc sine of is not on the unit circle, then you're either going to use your calculator or you're going to use some other method, which I'll talk about in one of the upcoming examples. These are solvable. A, B, and C are solvable using unit circle. D, you got to take out the handy dandy calculator. Don't do problems like A, B, and C with a calculator. This we already talked about. I used it in the example when I converted from an arc sine problem to a sine. If you take the function of the inverse, you get back to x. We knew this already because we defined an inverse following those rules. The inverse of the function is x. The function of the inverse is x. However, you're going to run into some problems where they won't necessarily cancel. This would be true if we looked at all possibilities. But by restricting quadrants, we're going to run into some issues. Okay. So, for instance, what's that?
1/2.
No.
Oh. Wait, what?
It's not. It's not. It's not. Couldn't tell you what it is, but it's not.
It's too easy of a question, it's not.
You think it's a trick question?
Pi over 6.
I want you to say 1/2 so then I can point and laugh at you when I click on the board and it's not 1/2.
Yeah, well, I'm not gonna say 1/2.
Pi over 6.
You're not going to say 1/2? Oh, you should have. It's 1/2.
Oh, yeah. Eric, stop trying to read it, everyone.
Why is it 1/2?
Because those cancel.
They cancel.
Then why doesn't the last
Sine and the arcsine cancel.
How about that one?
No. It's not that. I mean,
Negative pi over 4.
Seems logical, right? Nah, it's not.
Yeah.
Pi over 4.
Good.
So what's the difference between the two?
The first one is because it's the sine to the negative one and the signs cancel. And then the second one is the opposite, so it just doesn't work that way.
No. But that's a good guess. Yeah. You're looking at the fact that I took the sine of the arc sine versus the arc cosine of the cosine.
Yeah.
No, it has to do with the location of the values that we're talking about. Okay, so here we're taking a sine of 1/2. That's in one of the quadrants that we've restricted sine to. What quadrants did we restrict sine to? 1 and 4. However, in the second one, we have a value of negative pi over 4. What quadrant is negative pi over 4 in? 4. But 4 is not one of the quadrants we restricted cosine to. Cosine is restricted to 1 and 2. So you have to do this the hard way. You have to first find where is that. Or what is that value, I should say. What's the cosine of negative pi over 4? 1 over root 2. So this becomes the inverse cosine of 1 over root 2. What'd you say? Okay.
Good answer, Leslie. No worry about it.
What is the inverse cosine of 1 over root 2? Initial reaction would be negative pi over 4, but again, that's in the fourth quadrant. We don't want to be in the fourth quadrant with cosine, so therefore we get bumped up to, yes?
Can we just like, without doing that work, can we just like switch it of the negative and just put pi over, like, you know what I mean? Like, or will it not always work out that way?
No.
Okay.
So the inverse cosine of 1 over square root of 2 is right here, which is pi over 4. So again, if the thing that you're working with is in an area that is satisfied by the restrictions, then you're good to go and they'll just cancel each other out. If it's not, then you got to do it the hard way and do it as a two-step problem. Okay, how about that guy? What quadrant is cotangent restricted to? 1 and? I'm sorry?
2.
1 and 2. Where's 2/3? It's not. So we need a new technique. I love when everybody has no clue and then finally somebody goes, it's not? This is where you go back to the triangle method. You did this in Precalc.
Can we do that like all the time?
Sure.
Okay.
Might not be right, but you can do it. You can do whatever you want. This is
We'll do it
America.
all the time.
I've got some angle theta. When I take the inverse cotangent of theta, I get 2/3. And what is cotangent? Well, cotangent is cosine over sine, which it which is, as we all know, the cotangent is adjacent over opposite. So I've set up my triangle in such a way that we would get adjacent over opposite. How do you find the hypotenuse? Or I should say, what is the hypotenuse? I'm sorry? Square root of 13? Good. So then what is the cosecant? If this becomes the square root of 13, then what's the cosecant of that triangle? Let's see, cosecant is 1 over sine. Sine is opposite over hypotenuse, so the cosecant would be hypotenuse over opposite, which would be square root of 13 over 3. This business in the parentheses only serves one purpose, and that is to get the triangle. Then this could be any one of the 6 trig functions. So for instance, what is the tangent of the arc cotangent of 2/3? I'm sorry? 3 over 2. Beautiful. Moving right along. Now let's get rid of the numbers. Let's use a variable. Okay, so what does this first statement mean? Or what does it mean? There's some angle, what do you want to call it?
A.
Theta.
Theta.
Run.
Use theta, right? Let's use beta. There's some angle beta that when I take the sine of it, I get x, which is the same thing as x over 1. So what would your triangle look like?
The hypotenuse is 1.
And?
The other one side is x.
Good. Now back up there. So how long is this?
1 minus x squared, or square root of 1 minus x squared.
Beautiful. And therefore, what's the cosine of that triangle? Go ahead, Gray.
I didn't know you raised it.
I
Square
understand.
root of 1
Okay.
minus x squared over 1.
Good. So easy peasy. Let's solve an equation. Yeehaw. So now I've put the variable in with the arctangent. What do you think I'm going to do first? How do you get rid of arctangent? Not multiply by tangent. Can't multiply by tangent. Yeah, take the tangent of both sides. You get that. What's the tangent of the arctangent? Cancels. We know the tangent of pi over 4 is 1. Hopefully you know that. And then I hope it's safe to assume that you can all solve that linear equation. What's x, just for giggles? Did you answer that with a question?
I
2?
answered it sarcastically.
Oh,
I
a
said
sarcastic
10.
question. You said 10.
Yeah.
Oh, even better. Good. Yeah, that's great. All right, that's the review stuff. Here comes the new stuff.
Oh my god, why?
Why is this?
No.
I'm not ready.
That was not review because I didn't learn that last year.
You're a liar.
That's like a memory.
Well, okay, no. You might not be a liar. You may not have learned it last year, but someone tried to teach it to you last year.
No one tried to teach that to me
No,
last year.
No.
Liar, pants on fire.
no,
Who did you have for pre-cal?
No, we should let's play.
All right, I'm gonna talk to them and see.
We played.
You what?
We played
Ed Brady, we
Let's see. Inverse trig functions or fun run? Nah, screw it. Let's do fun run. This isn't as intimidating as it looks because you pretty much just did this in the last problem.
Pretty much.
Look at cosine. It looks very similar to what we just did in the last problem, except there's some u's in there.
Do we have to memorize this?
Yes.
Time to write it all down.
There's a good idea.
We'll just leave it on the screen, but just if for that.
I'll put it back up once we move on. I'll give you a couple minutes. If you don't get them all, we'll come back to it.
Oh, when you put
Oh my
parentheses
God.
That's
with a
bad.
bracket.
Oh, Grant.
Did you just do that?
No, but when I think I tried to teach down that thing and I took it and I taught to him.
It was the day before a test and you taught him the exact wrong thing and he like failed it.
Wow.
That was so cool.
That's what friends are for.
I like didn't mean to, I thought
She taught him 3069 triangle incorrectly.
Alright, he didn't know what it was, so.
Yeah, it's his fault.
He knew better after.
Well, you came into it and out of it with the same knowledge, right?
It's an absolute value. Why is that more thing?
It's just not a thing.
We won't tell anyone if we just skip it.
You can skip it.
We won't tell anybody.
Okay.
So it's, you know,
Yeah,
You're right, we did lose.
It's not like on the AP test, you're gonna have 35 questions with inverse trig functions.
Probably not.
No. This is not as life-threatening for the AP test as it is for the chapter test that's coming up in a week or so, where you will need to know them.
You're just gonna write it on the back page, right? You're just gonna write all the equations.
I
on
just
the
write it
back
on your
page?
forum.
I need to.
I assume this will not be on the quiz tomorrow.
No, quiz only covers 5-5, up through 5-5, I should say.
And then our first quiz was
Just 5-1, 5-2.
Mr. Schmidt,
Okay, let's move on, and then, like I said, if you didn't get these copied down, or you wanna check them to make sure they're correct, we'll come back to it. Okay, so this is where they came from. So I started with the inverse sine function, and I want to take the derivative. So I did the step that we already talked about. I took the sine of both sides. The sine of y equals the sine of the inverse sine. They cancel. We get to that. There's our triangle. Again, doing what we did in the last example. And then I took the derivative implicitly. So what's the derivative of the sine of y?
Cosine y dy dx.
Yeah?
Is it the cosine of y dy dx?
Right. Or cosine of y prime. Yeah. And what's the cosine of, oh, sorry, what's the derivative of x?
one.
Oh, this might not go well. So we get that. Because
You okay? I'm great.
this we can find. How do we find this? Well, notice y is our angle there. So what's the cosine of y?
Square root of 1 minus x squared.
Right? So we get the derivative. The derivative of y with respect to x is 1 over the cosine of y. And as Grant just mentioned, the y is equal to that business. So we get that. This is identical to the formula on the previous screen. The only difference is the previous screen had some u's in there instead of x's. So let's suppose instead of an x, it was a u, some other function. What would you need to do?
Same thing.
Yeah, but if it's not just an x and it's a function, what do you need to do? Rhymes with crane.
Train.
Rhymes with train.
Brain.
Lame.
Brain.
Lame.
That doesn't even.
Is that what you said? Lame and train don't rhyme.
That's good.
Sorry?
I like that.
Chain.
I
Yeah.
said chain, and you guys all make fun of
You
that.
said
You did.
train. You said train.
I said chain.
You said
No,
train.
You said train.
Train.
I said chain.
It just sounds like a.
No, I just have a stutter problem, not your That's not.
Wait for
Oh,
people in wheelchairs.
Mr. Shortest Guy who's the guy in the wheelchair.
Awful.
I didn't mean it like that.
I don't know what's worse, like
Right.
when
So notice if we go back.
she was in the wheelchair or she said she was in the
Okay, so there it is. Same thing that we just did, except instead of an x, it's a u, and you have to remember to chain on then the derivative of u. So you could conceivably go through and derive each of these formulas. Are you going to? Absolutely not. But I don't just like to give you things without explaining where they come from. So if we did cosine, we would do it the same thing. Our cosine equals, our cosine of y equals x, then take the, or sorry, I got that backwards. Y equals our cosine of x. Take the cosine of both sides, go and solve the problem. You'll end up with this, but there'll be a negative sign in front there, and we have a u prime there, so you got to remember to chain that on. More than likely, what's going to happen is you're just going to memorize these 6 formulas. And it will then lead you to, uh-oh, battery low.
One's
Die.
Oh.
Die.
Oh,
Die.
is that right?
Out of batteries? No more time for notes? No more time for notes?
Yeah, I did.
No more time for notes.
It's not supposed to.
Eric, take all those batteries.
Throw it out because it doesn't like what it is.
Is that what it is?
You ready to fight?
Hey, he's my friend. Alright?
So we're gonna back him up.
No, I'm letting you do it. I'm gonna record him. We'll
You're from Wilson?
Okay, so we get to this. Seeing as you have the formulas right in front of you, and eventually they will become part of you, whether you memorize them or practice with them or whatever. When you start the derivative of an inverse function, as it says up there, you want to ask yourself, what is u? So in this case, u is 2x. Apply the formula. U prime over the square root of 1 minus u squared. You have to square the whole thing, not just 2x squared. It's 2x quantity squared. And we get that. Any problems with the first one?
Wait, why'd you square the bottom?
Because that's what the formula says to do.
Oh.
Second one, what's u?
3x.
3x. What's u prime?
3.
3. Plug and chug. Okay, so look at the formula for the inverse tangent. It's u prime over 1 plus u squared. No square root there. Plug and chug and simplify. So if you can get a grasp on those formulas, this stuff isn't real tricky.
So those are just the answers, or what?
Yeah, that's it.
Was that what the problem would be?
Yeah.
That's what a problem would be?
C gets a little trickier because I chose a nastier function. U in this case is the square root of x. That's okay, you can work with that. Square root of x is x to the 1/2 power, so the numerator here is u prime. Bring the 1/2 down, reduce it by 1, so 1/2 times x to the negative 1/2, times the bottom, which is 1 minus u squared. U is the square root of x. Square root of x squared is x. Is that an acceptable answer?
No.
No, for 2 reasons. Why is that not acceptable?
Fraction, fraction.
Negative exponent and fraction within fraction, so when you clean it up, it becomes that. You don't have to bother bringing that square root of x under the other radical symbol, just leave it like that. I did, but you don't have to. Last one. What's u?
E to the 2.
E to the 2x. What's the derivative of e to the 2x? Times 2. Thank you, Jake. Itself times the derivative of the exponent. So u prime over u times the square root of u squared minus 1. Conveniently enough, those e to the 2x's cancel, and we get eventually down to that. Remember, e to the 2x quantity squared is e to the 4x. Power raised to a power you multiply. There is an absolute value, but it went away because e to the 2x is always positive. Just a little note there. Again, better to leave the absolute value symbol and not need it than to need it and not have it. All right, this is all, these 2 screens are all of the different things that we've done taking derivatives. I'm not going to go through all of them, but I'm going to point some of them out so you recognize what they are here versus what they are by what you know them. For instance, what is going on in number 4? Quotient rule. How about number 3? Product rule. Number 6? The other one. Power rule / chain rule. Good. Derivative of a function times a constant is the derivative times the constant. Okay, so all those are fancy ways of saying things that you already know. Once you get into stuff like, well, 7, hopefully when you get into 8, 10, or 9, 10, 11, 12, those are the ones we've just covered, and then on the second page is all your trig stuff. Okay, this stuff is in the book on page 378. So do you have to go and write them down? I hope not. I hope that 1 through 6 are already burned into your brain. I hope that 7 is included in that. We haven't done a lot with 8, but 9 through 24, you need to know all of those. But again, some of them you already know. You should know Where are the trig ones? Next page. You should know 13, 14, 15, 16, 17, 18. And then the last 6 are the new ones. Okie doke.